So here they're just saying simplify. Simplify. So what are we going to simplify? We're actually given what? We're given cos squared theta. And then also what? Multiply by tan theta. Can you all hear me?
Yes, sir.
Okay. Plus tan theta multiply by what? Sin squared theta. So they give me something like this. They want me to do what? To simplify. So the first thing that I will do actually, can actually see that here we are having a common factor of tan. So since we're actually having a common factor of tan, what basically you're going to do, you're going to take tan theta as a common factor. So you just say tan theta. Then after writing tan theta as a common factor, you say open bracket, will be left with what? Cos squared theta plus sine squared theta. Do you all see? Do you all see?
Yes, sir.
And then after this, L1, did you also see? So you write tan theta is this. Okay. Open bracket. Then you can rearrange starting by sine squared theta plus cos squared theta. So here it's a matter of rearranging the two. But I've just taught you to say, if you still remember from the what we call the square identity, if you still remember. Square identity on your notes. I said sine squared theta plus cos squared theta to actually give you 1. So where there is sine squared theta plus cos squared theta, you're going to write 1. So that's why hence I said, let us rearrange it because it's not everyone who will be able to see that that is an identity of 1. So since it's sine squared theta plus cos squared theta, you understand that it gives the identity of 1. Then it means to say here, what are you going to write? You're going to write, since they're saying simplify, we'll just say tan theta, open bracket. Since we now know from the square identity that sine squared theta plus cos squared theta is equals to 1, we just write 1. And then the next step that basically you're going to do from here, it's you multiplying. You're going to say tan theta times 1, then that will actually give you tan theta. So that's how basically we solve the first question. Any question? Any question?
No, sir.
Okay. Luanze, any question? Any question?
No, sir.
Okay. So here, since I think I was introducing that part in passing, I'm just going to introduce what you call the reduction formula in a broader perspective. Reduction formula. So basically, when I speak about the reduction formula, I'm speaking about that one of a Cartesian plane, if you still remember. So remember, I told you that you're going to always have a Cartesian plane, which that is going to be 0, 360. Then that will be 90. That will be 180. That will be 270. Then that is 360. So it's all students take coffee. And then you now know that the first one, we call it the first quadrant, if you still remember. First quadrant. Then this one is second, 2ND quadrant. Then that is the third quadrant, don't forget. Third quadrant. Then this one is the fourth quadrant. Then since now you understand that we're actually having 4 quadrants, your reduction formula, if you're going to use 180 minus theta, it will be as follows. So if you're going to use the reduction formula of 180 for 𝗶 minus theta, this basically means to say you're going to have the following reduction formulas. So here we'll have the one for what? Sine of 180 minus theta. So you must understand that that is going to be sine theta. Because when we say 180 minus theta, we fall on the second quadrant. On the second quadrant, sign is positive. That is why I'm writing sine theta. And then if you're gonna have sine of what? Sine of, not actually sine, because the one for sine we did it just now. So the next step is cos. You're gonna have cos of 180 minus theta. 180 minus theta, it's in the second quadrant, and in the second quadrant cos is negative, so it means to say that will be negative cos theta. So please write them the way I'm writing them so that you'll be able to understand them. Then if you're gonna have, say, tan of 180 minus theta. So 180 minus theta we fall on the second quadrant. On the second quadrant, we can actually see that tan is what? It's negative. So it will be negative tan of theta, just like that. And then for the one of 180 plus theta, let me just write it here. So I'm just gonna write that one here. So this one of 180 plus theta, if we will say, if we'll actually say the sine of what? The sine of 180 plus theta. We can actually see that 180 plus theta, it falls on the what? On the third quadrant, and then on the third quadrant sine is negative. Okay, so it will be negative sine theta. And then the second one, if we're gonna deal with cos, so it will be cos of 180 plus theta. So 180 plus theta, we know that it's in the third quadrant. In the third quadrant, cos is negative. Hence, this one will become also negative what? Cos of theta. Then lastly, we're going to have the one for tan of what? 180 plus theta. So when you say 180 plus theta, we are on the third quadrant. And then on the third quadrant, tan is positive. So you say tan theta or positive tan theta, just like that. So these are the core functions for what? At the reduction formula, so to say, for 180 minus theta and 180 plus theta. And then if you understand those, then I think you'll be on the safe side. So continuing onwards, you also have the one for what? The one for 360 minus theta, right? And then here we're going to have the ones for what? 360 plus theta. So on the other side, here we're going to have the ones for 360 plus of theta. So now let us write it them properly. So we know that if you can say sine of 360 minus theta, decrease minus theta. You ask yourself, from which quadrant do you have 360 minus? So 360 minus, we are on the fourth quadrant, and then on the fourth quadrant sine is negative. Hence, it will become negative what? Negative sine of theta, just like that. Then if you're gonna say cos of 360 minus theta. So 360 minus theta, we are on the fourth quadrant, and then on the fourth quadrant, what happens? Cos is positive, hence this will become cos theta. Do you all understand? Do you all understand?
Yes, sir.
Okay, cool. And then lastly, we are having the one for what? Tan of 180 minus of theta. So 180 minus theta, we're on the second quadrant. On the second quadrant, tan is negative. Hence, it will become negative what? Negative tan of theta. Then now we delve into making sure that we do the ones for 360 plus. So this one, it will be sine of, so this one, it will be the sine of 360 plus theta. So 360 plus theta, we are on the first quadrant. Then on the first quadrant, all of them are positive. Hence, this one will become what? It become positive sine theta. So here you'll just write positive sine of theta. And then if you can say cos of 360, cos of 360 plus theta, still the same applies. 360 plus theta, we're on the first quadrant. On the first quadrant, all the equal ratios are positive. Hence, it will become cos theta. And then we're also having a tan of 360 plus theta. Yes?
For the tan, why did you write 180 for the 360?
Oh, yeah. Thank you. Here, ne? Thank you so much.
Yes, sir.
So this should be, yeah, it was just a misprint. So tan of 360 minus 360 minus, we're on the fourth quadrant. On the fourth quadrant, tan it's negative, hence it becomes negative tan theta. Thank you so much. Ne? Please also fix that one and there. And then continuing onwards, you're having this one of tan of 360 plus theta. So 360 plus theta is on the first quadrant. On the first quadrant, all the correlations are positive. Hence, this one will become tan of theta. So if you can know these tables, I think we'll be on the safe side. 360 minus 360 plus. Not only those ones, you can actually see that I actually showed you the one forward, 180 minus as well as 180 plus, because in most instances, if you deal with trigonometry, they will ask you either one of those correlations that I've just written. So since now you understand that, I think now it will now make our work to be much easy. Ne?
Yes, sir.
So yes. Okay. Let's continue now. So we're still gonna do more trigonometric identities, but for now, let's continue. So they're saying it's an example. It's an example, so I'm gonna save it as an example, but the question is down page 74 on the textbook that I've just sent. So they're telling us that the point P, it's what? It's 7 and 12. Ne? 7 and negative 12, so to say. And negative 12, so to say. They're telling us that lies on the terminal ray of beta in the standard position. And then in that regard, they're actually drawing us a Cartesian plane that is like this. 90, 180, 270. So since they're saying it's a point P, you ask yourself a question. Even if they didn't write, you understand that that's going to be X here, that's going to be Y. And then you always make sure that you are having X, Y, and R. Are you with me? So this basically means to say our X is 7, yes. And then our Y is negative 12. So you must also find R using the theorem of Pythagoras, because the theorem of Pythagoras says the hypotenuse side squared, which is going to be R squared, is equals to the sum of the squares when there are two sides, which is what? R squared is equals to X squared plus Y squared. And then the next step is a matter of you substituting. You can actually see that we want R. So we're going to say R squared is equals to the value of X. You can see that that is 7. So you'll just say 7 squared plus, and then the value of Y is negative 12. Make sure that you put brackets so that you don't get wrong answers. So that you don't get wrong answers. So now let's continue. So it's going to be R squared. It's equals to 7 squared, it's 49. Plus minus 12 inside the bracket squared is going to give you 144. So let's add the two. 144 plus 49. 144 plus 49, what do you get? What do you get, guys?
193.
193. So it's 193. And you don't want R squared, but you just want R. R is equals to the square root of 193. Which is, you leave it like that. And then, now we are going to draw our Cartesian plane. Because now we understand that our X is positive. So if X is positive, it's going to be there. Ne? And then Y is negative, it's going to be there. So it means to say, now as you draw your diagram, a diagram with the 2 points they meet, remember, this is like this. Let me show you. Right? With the 2 points they meet, remember, you draw the diagram just like that. So your X here, it's going to be equals to 7. And then your Y there, it's going to be equals to negative 12. Did you move something on the screen? Ne? R is equals to
Sorry, I was trying to zoom in.
yeah, square root of 193, because I can literally see. Then now let's continue. So now if you're having X, Y, and R, you are more safe now, right? And then Dangiti, what is at the point P7 and minus 12 lies on the terminal ray of beta. So it means to say here the terminal ray here of this angle is given by beta, just like that. Then doesn't determine the length of OP. OP, you understand that that is the hypotenuse side actually. I'm sure this one is O. The center is always O. And then this P, they actually told us to say we are having point P, which is going to be 7 and negative 12. So that OP is the distance of the hypotenuse side. So you just say OP is equals to R, which is the hypotenuse side, is equals to what? Square root of 193 units. But we are not yet done. Let me show you. So since the first question doesn't determine the length of OP, length, that's what I'm saying units. So you'll just say OP, it's approximately, then you say square root of 193 because you want the length. That's 13,89 units. So if you want, you can just say OP, therefore, OP is approximately what, 14 units. Just like that. Or even if you write 13,89, it's not going to affect you because that 9 it round this date, it becomes 13,90. And then that's the first question. And then the second question, number 2, under this, it's a continuation. They want us to determine sine of beta. Did I teach you SOHCAHTOA? Did I teach you SOHCAHTOA, guys?
Yes, I think you did here because I have it.
Yeah. So when you talk about SOHCAHTOA, S stands for sine. So you're going to use this. So,
Sir, can I ask you?
Yes.
I ask you a question?
Yes, you can ask.
Yeah. When they say calculate the length of OP, can't we just use is it a must to write it in the decimal form?
In a decimal form. Yeah, you know why? Because the question paper, it will say correct to 2 decimal place unless stated otherwise. If they want it in 1 decimal place, then you adhere to the question.
So when they say calculate the length of OP, and I don't actually write it down like this. I'll get the root and then I'll plug it into the Cartesian plane. If I leave it like that, will I get those marks?
You might forfeit marks, but just because of its length. Let me show you something. Let's say you are building a house in your yard. So there's no way you can have maybe 18,89 meters. So just because of its length, we normally, in most instances, round it to the nearest whole number. Because if your yard, have you ever seen a scenario whereby they're saying someone buys a house and then he bought a house that is 13,89 meters? No, you'll never find it like that. Length, we omit the commas and then we concentrate on the one that is a whole number, just like that. Did I answer you?
Yes, sir.
Okay. And then since we are using sine is opposite of hypotenuse. So you'll say opposite over hypotenuse, we say R. So what is your opposite side? So your opposite side is represented by what? By negative 12 there from the diagram. We normally use the diagram that we have. So that is going to be negative 12 over the hypotenuse side, which is the longest side in the triangle. So the hypotenuse side, which is equals to R square root of 193. You get to see that. But you won't write it as in a decimal form. So rather you write it the square root of 193. Of which you understand that maths doesn't allow us to have many division signs. So if you don't write the square root of, if you don't write minus 12 over square root of 193, this is how you can write it. So remember, it's minus 12 over the square root of what? 193. So if you rationalize the denominator, Okay, it gives us minus 0.86. So leave it like that. So leave it like this. For now, you'll be correct. So that's the first one. And then on number 2 or number 3, what do they want? They want cos beta. So if they want cos beta, you ask yourself a question from SOHCAHTOA. Cos it's adjacent of hypotenuse. So this one is going to be adjacent, which is represented by x of hypotenuse, which is represented by y. And then let's now check what is the value of x. So the value of x is 7. You write 7 over r square root of 193. So you just say, let's double check if it's simplified into the first form. 7 over square root of 193 gives us 0.5. So you just leave it like that. Any question? Any question?
No, sir.
No question.
Okay. Here the one side beta multiplied by cos beta. So here, since they want sin beta, look at this sin beta, we got this. So you're going to write that in terms of sin beta. It will be minus 12 all over square root of 193. Multiply by, let's check cos beta. Cos beta is this one, which is 7 over square root of 193. So since they say without the use of a calculator, or that one, let me do it aside on the script with the pencil. Square root of 193 times square root of 193. It will give you square root of 193 all squared. And then square root, you know that it makes it approximately equals to half. So square root will cancel 2, and you are left with 193. So it means to say on the denominator side, you are left with 193. And then on the numerator side, we'll say minus 12 times 7. So what is minus 12 times 7? A
Minus 84.
minus 84. So here you'll write minus 84. So you can just leave it as it is. Minus 84 over 193. So this one cannot never be simplified into the first form. It means to say that is the correct one. Then now we continue. They want us to find the tan of, is it tan beta? Yes. Tan of beta. So remember, we are having a SOHCAHTOA. Tan is equals to opposite over adjacent. It's going to be opposite over adjacent. And then we are now going to check, because I'm getting it from SOHCAHTOA. Let me show you. So SOHCAHTOA. So that's sponsor there, which is tan. Tan is opposite of adjacent. So opposite to show it with y, adjacent to show it with x. You are safe. And then after that, you now substitute what is the value of y. You go back to your diagram. Y, it was, I think, negative 12. Yes, y is negative 12. So you just say negative 12. You come back here, you just say minus 12 all over the value of x. Let's check what was the value of x. X, it was 7. So you're going to write 7. So it means to say this, it can never be simplified into the first form because we are actually getting disturbed by this 7, but it's correct to do. So it means to say that's how basically we deal with that question. Any question?
No, sir.
Okay, since there's no question.
No questions.
Okay. I'm trying to see where best can I solve. Is there any one of you who has also a different math textbook from the one that I sent?
Yes, sir.
Can you please send
Yes,
it on the group? I just want to take questions based on this.
I don't have an online one, so
Oh, okay. No, it's still fine. Don't worry. Still fine. Just a second. Let me see what
Mhm.
basically.
I can send mine right now.
Yeah, please send it so that we look at more questions on trigonometry. Please let us know just now, Lonely, when we are done. And it's just that the ones which now I'm having on that textbook, they are a bit advanced questions. So the way I teach maths, I don't like rushing into doing topics which you might not understand for now. That's why I'm saying we are in the early stages of trigonometry. So hence we are dealing with trigonometric identities as well as the type of equation that I just said. Winnie? Are you winning, Lonely?
Yes, sir. Can I just 1 second?
Okay. I'm also searching more of this. Okay, there you
Yes,
go.
sir. I just send it right now.
Okay, let me double check it. Did you send it? Let me check. I'm not seeing anything.
Yes, sir.
Luan,
It's 50%. It's coming in.
okay. I also have more of the textbooks. It's just that they're on the
You should
laptop.
see it in 10 seconds.
Okay. It's just that mine, they're in the laptop. Just a second.
Yes, sir. It's done, Vanessa. You should see it now.
Okay, thanks. Let's see it. Oh yeah. It's also one of the good textbooks, that one. So let's go to trigonometry. Trigonometry. It's page 1. Page 103. Yeah, somewhere there. Yeah, thanks for sending it. I think it has more questions. So let's do. Apologies for that. So let's say you are having cos of 180 minus x. I was just looking for questions. Multiply by cos of 90 minus x. And then multiply by tan of a negative angle, negative x. All divide by what? All divide by sine of 180 plus x multiply by sine of what? Sine of 90 plus x. So you can actually see that some of this I've just explained there. So there are 3 formulas which they're very important. I'm going to write them here, which is the first one. It's a sine of a negative angle. Sine of a negative angle, you're going to get negative sine x. You must know these 3 formulas. Cos of a negative angle is equals to positive cos x. Then tan, lastly, tan of a negative angle is equals to negative tan x. Then from this, the only one which is positive is this one. Yeah, the only one which is positive is this one. So now let's continue. So since here we are having a Cartesian plane, 0, 360, 90, 180, 270, 360. All students take coffee. When they say cos of 180 minus x, 180 minus x, you are going clockwise. You follow on the second quadrant. And then on the second quadrant, cos is negative. So it means to say here we're going to have negative cos x. Not only that, multiply by cos of 90 minus x. 90 minus x is on the first quadrant. Then on the first quadrant, all the correlations are positive. But taking into consideration that if you're going to use 90 and 270, it's now becoming a co-function. It means to say they're going to change. So it means to say since it's cos 90 minus, it will change into what? Into sin x. And it's positive sin x because it falls on the first quadrant, because on the first quadrant, all the correlations are what? Are positive. And then multiply by, look at this one, it's tan of a negative angle. Tan of a negative angle is negative tan x. So it means to say also open bracket negative tan of x, just like that. And then here you'll say divide by sine of 180 plus x. 180 plus x is anti-clockwise. And then we are on the third quadrant. On the third quadrant, sine it's negative. Hence, this one, it will be negative sine x. Are you all following? And then
Yes, sir.
sine of 90
Yes,
plus.
sir.
Okay, cool. 90 plus is it's anti-clockwise, and then we follow on the second quadrant. On the second quadrant, we know that sine is positive. Hence, but just because of its sine 90, it means to say to change into positive cos x. Just like that. So for you not to make mistake here, let's do like this first. So you can actually see that this one. Let's now cancel signs only. Negative cancels negative. Then cos x cancels cos x. Sin x cancels sin x. It means to say the final answer that you are left with is going to be negative tan x. So here you just write negative tan of x, of which that's going to be correct. Yes, I'm very correct. 140. If you look at number B, we got negative tan x, just like that. Any question?
No, sir.
Okay, cool. And then the last one for today, if you're having sine of 90 minus theta, multiply by sine of theta, divided by what? Divided by cos theta. Cos of theta, multiply by the cos of 90 plus theta. So this is what you're going to do. Sine 90 minus theta, 90 minus, we are on the first quadrant. Then on the first quadrant, all the co-ratios are positive. But since it's sine 90, it means to say it will change into what? Into cos of theta. So you must be very careful of that. That's why I'm writing it with a different. Then we are multiplying it with sine theta here. All divided by, you're also having on the denominator, you're having cos theta, multiply by, and then cos of 90 plus, it's going to become negative sine theta. This one, it's going to become negative sine theta. The reason why I'm saying it's going to become negative sine theta is because of its cos 90 plus. 90 plus, if you check here, it's 90 plus. It means to say we are on the second quadrant. And then on the second quadrant, cos it's what? Just a second, is cos 90 plus is 90 plus. Okay, let me write it here. 0,360, 90, 180. All the students take off 270. So let's double check it again. So it's cos 90 plus. 90 plus, we are on the second quadrant. And then on the second quadrant, cos is what? Cos is negative. Hence we'll write negative. But this cos it will change into sine. Then it means to say we are what? We're 100% correct. And then from here, what basically you'll do, cos x cancels cos x. And then this goes once, that goes once. So here you can see that you're having 1 divided by what? Divided by negative 1. Hence the final answer will become negative 1. Because you're having 1 divided by negative 1. 1 divided by negative 1. It means to say you're getting negative 1 is the final answer. Any question?
No, sir.
You all understand?
Yes, sir.
Okay, I'm just gonna send.
Yes, sir.
Okay, cool. So for today, we'll just end up here. Let me just send the work on the group. And then the work that I've just sent is the one that you'll actually do as a homework. Ne? Must do exercise
Yes,
for
sir.
on page 140. Let's go and do all of those. And then when I come back, I'm gonna do corrections. So there are how many? 1, 2, 4, 6. There are 6 of those. Ne? So it means to say, on our next session, I'll be basically teaching you the correction part of that exercise number 4. Do you all see that exercise number 4 that has 6 sums? Do you all see it?
Yes, sir.
Yes. Do you also see it?
Yes, sir.
Okay, cool. So yeah, that is it with regards to basics. I believe that you learn more. As long as you are willing to learn, I believe that you learn more. So yeah, that is it. Don't forget the reduction formula for both 360, 180, 19, 270. Sharp, sharp, guys. Bye.
Goodbye.
Bye.